mentioned earlier, I'm going to post every recording to Canvas. So if you're gone from class and you want to know what we did, this is a great place to start. If you just don't get it and you want to review the recording and watch what we did in class again, maybe in class you were really tired and now you're at home trying to figure it out and you're not. So watch it. Okay, that's why I record them, so that you have an opportunity to reteach yourself, think about things. Okay. So let's go through this textbook check. During the video, James Souza, he's going to be the one that usually has that yellow background on his videos. So there's going to be times as we go through that I may say James Souza was the narrator in this video, or the producer of this video, true or false. Well, just go back in your mind, was that video I watched, was it the guy that has kind of that yellow background screen? That's James Souza. Okay, quite a few of the videos this year will be from him. I think he's good if you just pay attention to what he's saying. So during the video, James Souza discussed an example with a repeating decimal. Repeating decimals are considered what kind of numbers?
Rational.
Rational. So what I want to give you for a trick, I'm trying to keep rational, irrational, all of those separate, and why a repeating decimal is a rational number. Give me an example of a fraction that gives you a repeating decimal.
Pi.
Nope. Pi doesn't repeat.
Oh, no. 3.3333.
Give me a fraction that gives you the 1/3. Perfect. Okay. There's millions. There's infinite number of examples that give you repeating decimals. But 1/3 is an example of repeating decimal. So 1/3 we know gives us 333 repeating, or I can just do it this way, right? 1/3 gives us 0.3, not 3.3. Sorry. Okay, that's an example of a repeating decimal. A fraction is a ratio. Have you heard that before? I mean, hopefully from elementary. A fraction's a ratio. If I could say this is 1/3, or I could also say it's 1 to 3, it's a ratio. Okay? You're only going to get repeating decimals from ratios or fractions. Therefore, repeating decimals are rational. What's the first 5 letters in rational? Ratio. Okay, so think of rational numbers as numbers you get when you have a ratio. Okay? Can I write 3 as a fraction?
Yeah. Oh,
Yeah. So 3 is a ratio. 3 is a rational number. 1/3 is a rational number because it's also equivalent to a repeating decimal. Repeating decimals are rational numbers. Okay? Next question. Well, let's look at these first. We have rational numbers. We've just talked about what those are. Created by ratios. Okay? Natural numbers. What are natural numbers?
1, 2, 3, 4.
Okay? This is the way I think of it. I naturally have fingers. I can count natural numbers on my fingers. I don't have 0 fingers. I have, my first finger is 1, right? So 0 is not a natural number. Only the counting numbers, what I could physically count on my natural fingers, are natural numbers. Make sense? Okay. What's a whole number?
0, 2,
It's the whole numbers are natural numbers
and 0.
plus 0. Yeah. Natural numbers plus 0 are whole numbers. What are integers? Negative and positive. Are integers decimals? So they're whole numbers, but they also include the negative whole numbers, or negative numbers that are whole numbers that you make negative. Those are integers. Okay? So I think in the video or the textbook, we had this big circle that they identified as real, right? What would the next circle be? What's the bigger, well, we've got, so we've got rational here. Because isn't every integer a rational number? Because I can make it a fraction. Okay, I'm going to make my circle a little bigger. And over here, I have irrational. And I'll talk about those in just a second. Under rational, then, what's my next circle? Integers. because all integers are rational numbers. Then I go to whole. Then I go to natural. I'll just put natural. Because every natural number is a whole number. Every whole number is an integer. Every integer is a rational number, and every rational number is real. Okay? Irrational numbers are numbers that never repeat. So you gave one example a minute ago. Pi. Pi never repeats. The square root of 7 never repeats. Okay? How about the square root of 4? What is it? 2, which is a rational number. So don't get it in your head every time you see a radical that's irrational. That's not true. If you can simplify the radical, you'll be fine, and it's a whole number. Okay? But irrational numbers never repeat. That's the definition. Okay? So let's look here. Select the correct answer. The square root of 7.
That's great.
What is the square root of 7?
2.6 something.
3.645.
Okay? So it is greater than 2.5. Okay, this is really just kind of reviewing your number line and how you put numbers on the number line. Negative 2 square roots of 3 is what kind of number?
Irrational.
Irrational, because the square root of 3 is a root that I can't simplify to a whole number. If you put the square root of 3 in your calculator, it ends, because the calculator only has so many spaces. But the square root of 3, the square root of 7, the square root of 21, the square root of any number that you can't simplify to an integer is irrational. Okay, so the fact this number has a square root of 3 in it makes it irrational. True or false? Negative square root of 9 is an irrational number.
False.
False, because it's actually equal to negative 3. Square root of 9 is 3. So it is not irrational. And question 5, in the textbook, 5 steps were given in order to convert a repeating decimal to a fraction. These steps are given out of sequence below. Select the correct order. So what's the first thing you need to do when you're trying to, this was page 2 of the textbook, and there was an entire video on how to do this. Okay, set your repeating decimal equal to x. What? Find the repeating digits.
Move the repeating digits to the left.
5, 3, 4. Okay, I want to do a quick example of how to do a repeating decimal to a fraction, because you're going to have a couple web work problems on there. So is that okay if I take a minute to do an example? Mm-hmm. Okay. I might do 2 examples. And then I'll turn you loose. Okay, there's the repeating pattern. It repeats after 6, right? It goes 4, 6, 4, 6, 4, 6, 4, 6. So my goal with trying to turn these into fractions is to get 2 numbers that I can subtract that have the exact same repeating pattern after the decimal. Let me say that again. I want to subtract 2 numbers that have the exact same repeating decimal after the decimal, repeating numbers after the decimal, because I want, when I subtract them, I want to have just 0 after the decimal. That's my goal with all of this process. Okay? So I'm going to set this equal to x, because the pattern starts right here and it continues, starts right after the decimal. Now, for me to get another number that also has 0.46464646, I need to move this decimal over twice, right? Well, this goes back to your orders of 10. If I multiply the number by 10, how many times does the decimal move?
1.
1. By 100? 2. By 1,000? 3. So it's all factors of 10. Every factor of 10 moves it over 1, right? So I moved it over twice, so that's 100 times my original number, right? And that equals 746.464646, and so on. Okay? Now, I didn't line these up very well. Now I'm just going to subtract both sides. 46 minus 7 is 39. And exactly what I wanted to happen happened. My 4 6 canceled and I just got 0. So now I just solve this. Put that in your calculator. 739 divided by 99. This is a great way to check your math. 7.464646. Okay? Now, WebWork may not like this answer. They may want it simplified, so make sure you're always reducing your fractions, or WebWork won't take your answer. It has to be in the most simplified form. So what I could do here is either divide 739 by 9 or by 3, because those both go into 99. See if I can simplify it. Okay, but so this is it. This is the final answer. Okay, let's do one more. We'll make this one a little more challenging. What's the repeating pattern? 373737. So with the last problem, I set x equal to the original number because the original number started with the repeating pattern. This one doesn't. So I've got to get my x value. I've got to move this over twice to begin, right? Which is 100. This is x. So 100x equals 8.3737, right? Now I want to move the decimal to the next time it repeats. 2 more. So I've just added 2 more powers of 10, right? 100, 1,000, 10,000. And that becomes 837.3737. Right? Let me line these up better. Again, my ultimate goal is to get these to be identical. So when I subtract, I get 0. Okay? So 37 minus 8 is 829.0. 10,000 minus 100. 9,900. Right? If you need to use the calculator to do it, that's fine. Now, we're going to divide 829 by 9,900. What do you get? $11? I did something wrong then. It's correct? Yeah. Okay. So this answer would be over 9,900. And then again, simplify if you can. Okay? I recorded both of these examples. You're going to work in class now. But if you don't finish WebWork and you're working on these problems, remember you can always go back to Canvas and watch this again and walk through the problem with me as you're doing it. Okay? All right, so what I would recommend you do now is WebWork. I kind of said CK12 when you showed me that. I would do WebWork first. WebWork's going to be a little more challenging, and those are the ones I'd like to help you with. CK12 problems are extra credit, and they are due at the beginning of the day of our first test, our first quiz. Okay? So I'm not suggesting you procrastinate with CK12, but I would like to see if you're going to need help, that I'm here to help you with WebWork problems. So everybody go to the Assignments tab, and then you'll find WebWork 1.1, and you can get started. Did anybody not finish the orientation? I think, Maddie, you hadn't yet. Okay? The one from last night, yeah.
Okay. Yeah, I have done that.
You have or haven't?
I haven't.
Haven't. Okay. So because it's the first week, I will go ahead and reopen that and not take any points off for the orientation because I want you to get through the orientation. But starting today's assignment, it will be due tomorrow at midnight. Okay? So if you have questions, you come in tomorrow morning. Don't come in Friday or Monday morning because it will be closed. Does that make sense? Okay. Now, I will reopen things up, but as soon as I do, it does discount your grade by 10%. Okay, so if you get 100 on it after you work an extra day on it, then you only have a 90. So I'm not going to just say you can never do it because I want you to practice it. and still get some credit. But you just have to come let me know that you need me to reopen it. All right. Finally, first day of math. Been waiting for this day also.